Hey, good morning. I'm just catching up on emails after being being out for the Christmas break. I'm getting to all these emails here. So I wanted to cover this. I figured it'd be a lot easier to show this in an email in a video rather than try to type this out in an email. So I'm going to start over on the 2D side first. Okay, so I've already gone ahead and drawn out in this case here, I'm working with a harness. It doesn't have to be, connector to connector. It can be whatever kind of component you're working with, but I want to talk about the connection points, right? So I have my connectors here, or contactors, or breakers, or whatever it may be that you're working with. I have my symbol, right? And inside of that symbol, I have connection points. Okay. Now, those connection points are listed as terminal type connection points. There are a lot of different types of connection points that you can choose from. Um, I won't get too deep into that just yet, but there are not just terminal. I can also define, if I'm working with a PLC, I can define the digital ins and the digital outs and the analogs, and maybe it's power or comms. There's a lot of different classifications I can make this connection point. I personally, for me, for all intents and purposes, I just make everything terminal, but you can go down deeper down the rabbit hole if you really wanted to with what type of connection point you actually want. Why is that important? Because now when I link my manufacturer part to this particular connection point, the manufacturer information is also listed as a terminal, right? So these are all the different types of connection points I can use. There's actually a lot more in here, right? So relay coil, you can see all these different ones. Now, why am I bringing that up? Because this is the first step when you want to do any type of routing and make that handshake happen between the symbol and the manufacturer part. So ultimately, like I said, I just use terminal because it's kind of a default. There is also miscellaneous, what a lot of people use as well for just basic stuff. But in this case here, my symbol has 4 connection points. My manufacturer part that I built that's in my library also has 4 connection points. Inside the manufacturer part is where I can define A, B, C, D, 1, 2, 3, 4, like I have here for the marks, additional information about each connection point, obviously the properties about the overall part that we're working with, right? Once I have those linked, you'll notice that there's this green square here letting me know that I've made the connection. The symbol information and the manufacturer part information matches, giving me essentially a green light saying, yep, okay, these are going to work together. Now, why I brought up that information about the different types of terminals, that if I pick a symbol that has 4 pins that are terminal, and then I manufacture a part that is all 4 pins are listed as ground, it's not automatically going to connect. It's a design rule check to make sure that you're not cross connecting something that shouldn't be connected, right? Like you're not connecting, if you're using PLCs, you're not connecting a digital in to an analog out and then browning something out down the road. It's there to help you to make sure that things are being connected correctly. Overall, like I said, if you don't need to go that deep, then that's okay. You can stick to just doing things like I do with just terminals. Okay, as long as you get this green dot here, you're all good to go. So on the 2D side, I've got my symbol set up. I've got wires connected to from one side A to all the way down all over the place in my little harness here. Now, how do I get this over into the 3D side? How do I show that? So over on the left-hand side here in SolidWorks Electrical, I have my document tree and I have my component tree. Okay, so inside of mechanical, we're opening up I'm on SolidWorks 2023 right now. We have our feature tree, but I also have access to the electrical component tree, right? And we can see here that I have J1, J2, J3, all the different types of connectors we're working with here. Okay, so I've already placed them out in my assembly here, and there's a few different ways we can make that handshake happen between the electrical side, right? We have, in this case here, we have J1. We want to make sure we connect this to the right solid model over on the mechanical side, right? So there's 2 different ways we can really go about doing that, okay? And that is I'm just going to disassociate this to show the process. we can see here J1, my base component here, this part, okay, I don't have anything connected to it. There's no link to the mechanical side. So I can either say insert, which is going to go back to my manufacturer part library over on the electrical side in here. And if I have a part that is in this field right here, it's going to go and find that model and bring it up into my assembly. Okay. So it's going to pull that out. If I use that insert, it's going to find it, and then it's going to just show up and float around until I made it up where I want. Or what I personally like to do is I like to just jump in here and add all the parts that I know I'm going to use, as many as I can, and then I use this associate command right here. So I right click on that and I say associate, and I can zoom in on the part I want. Any parts that are already selected or already connected and a handshake has happened between the electrical mechanical side are going to become transparent. You won't select them. But this one here, like this, I'll just simply select it and hit the enter key. And just like that, you can see now that my symbol has changed. I now have a little solid part symbol instead of that transparent. It's a little new icon they created with like a little mini X on there as well. All right, so I've made that handshake between the electrical side and the mechanical side. Now, what's the next step here for my connections? Well, connection points, right? We defined the connection points over here in the electrical side, right? We have our connection points, but we need to make sure that in our 3D model now, our wires are going to route to the specific spot we want them to route, okay? So I've already defined them inside of my connection point. Let me see here. There we go. So I already got my connection points. Now, SOLIDWORKS Electrical prefers to work with solid parts, not solid assemblies. So if you have an assembly of a part or assembly like an electrical assembly, let's say you have some type of amphenol connector, for lack of an idea, like right, you have your housing, you have your pins, you have your back shell, you have a piece of heat shrink. All of that makes up the connector, but when you put it together in 3D, that might be an assembly. What I recommend doing, if you can, if you're allowed to, there's a couple workarounds, but what I recommend doing is saving that assembly as a part and then reinserting that as a part. And then that way all of those parts are in there. Now over on the electrical side, that information, the electrical side will still contain all of the manufacturer parts. So your bill of materials is still going to include the housing, the pins, the back shell, so on and so forth. You're going to get all that. But the model itself, you can just have the one part. Two reasons I like doing that is because it's going to clean up my feature tree. I don't have to have all that crazy stuff in there. It's just going to help with RAM, right? At the speed of my computer as well. And again, it's being captured with the bill of materials on the electrical side. So when you add your connection points, the one thing you have to do is you have to add those connection points in the part itself, not in the assembly. So I'm going to go to the part. I'll open that up. Let me hide these guys right now. I'll go show the rest of that stuff. And I have my connection points. Now notice on my connection points here that I have, they are not C points. They're not listed as a C point. They are listed as 0, underscore 0, underscore 1, 2, and 3. Now those are specific to SOLIDWORKS Electrical. If you've already gone ahead and used the Routing Library Manager, the RLM for short, right? You're going to get that big window that pops up and define the connection points. That's okay. You can go through that, but you need to make sure that you pick the electrical ones that will allow you to show this 0, underscore 0, 0, underscore 1. If you haven't done that, you need to go back into your parts and define it this way. These are what are needed to define and connect to electrical. Okay. Now, why are these different? Well, we're dealing with SQL here. So 0, underscore 0 is circuit 1, pin 1. So that actually corresponds back to our circuit, our manufacturer part, circuit 0 or circuit 0, right? This is our circuit here. So circuit 0, pin 1. Even though this is our mark, we can change that. Like I said earlier, we can change that to A, B, C, D, whatever we want, 13, 14, 15. So this is pin 1, pin 2, pin 3, pin 4. If I were to go in here and create another circuit, and we have our circuit here, right? Now I have circuit 2, pin 1, circuit 2, even though it's one of those I believe buttons you got to press dealing with SQL, right? So 0 is 1, 1 is 2 in here, and so on and so forth. Okay, get rid of that guy. All right, so that's the main reason why. So when you go ahead and route to your model, and it's going to look at your schematic and it's going to route exactly where you put this connection point. Now, another piece of advice, I didn't do with this and I should have. I just put the connection point right here at the face of this. In reality, this wire is going to probably come to about, I don't know, somewhere in here, maybe all the way out to here, right? Because you're crimping it and then shoving that pin into this little Molex connector. So these connection points, you could probably put in a little closer. It all depends on how small your device is and how detailed you absolutely need to be. Um, in reality, a lot of folks will just do this and then they adjust their report later on to include an extra 5% or something like that for every wire. They'll just manipulate the length that you capture on the back end later on. But maybe it's good practice for you to take that connection point and put it somewhere inside of the part. So that way, when the wire does come into this, it's going to stop at that connection point inside like it would normally would in the real world, right? But ultimately, you need to make sure that the connection points read this. In order to get to those, you need to you can use the electrical component wizard, or when you're in the part, you can use the create C point with circuit information with a manufacturer part information. So in this case, I know this is a 4-pin microfit connector, Molex connector. So I can come in here, I can find the part I want. I can search for the part that I want, and it knows this is the electrical. It's looking at my electrical library right now, right? So I can come in here and let's find that Molex connector and circuits 1. Let's see here. So like this one right here, right? So 04, that's the actual part, and it knows to be able to connect those. Okay, so then you would select one, and then what you should do is put a sketch point on that plane right here and just hit the green checkbox, hit the next one, green checkbox, next one, next one, next one. Right? It's pretty straightforward to add the actual connection points. Okay. All right. So now that you've added your connection points to your part, right? We have our connection points on our parts. Even these pins here, I did this as an example to show these are single pins going to, some people like to do this. I have 4 different in my schematic. I have just 4 individual pins. So there's 0, 0, 0, 0, so on and so forth, right there. There's only 1 pin for each one of these, just to kind of show that you can do that. So you have your connection points. The next step you want to do is your EW path. Okay, what an EW path is an electrical wire path, right? It's a path to let my wires know where they should go, right? Because if I don't put this in or I suppress this right now, I can route this. They're just going to route. They're going to route, but they're going to route where they want to route, and it's going to give you the shortest distance, right? It's the fastest or the the straight line, pretty much, right, from point A to point B. But in reality, we're going around a standoff. We're going through a bulkhead. We're doing whatever we're doing. We need to follow some sort of path, and that's where the EW path comes into play. So I don't even know the length of this, but I just tried to put them in different spots, just to capture this crazy looking harness looking thing here. So this EW path is super easy to build. What I recommend when you build this, what I personally like to do is I actually like to build a tiny little EW path segment into my part, okay? And that way it gives me a center point essentially to start from here, okay? So In order to add an EW path under the Tools Electrical tab, I'm in the part right now, not at the top level assembly. You can do it in either the part and you can do it at both each part and the assembly itself. You're just going to go ahead and say define routing path, okay? And it's a 3D sketch. So if you don't know how to use 3D sketch, just simply use the sketch command, the 3D sketch command, draw a line, and you can start at any point. You can see your origin. This is a nice little trick, a little tip here too, is that the tab key will help change the X, Y, Z axis. You can see that it's changing for me here. I personally like to try to keep my lines going along that path as best I can. And then later on, I can always adjust and add extra angles if I need to. But this just helps to make sure that I'm orienting in a nice straight pattern. I guess it helps my mild case of OCD, just making sure everything is nice and clean. Once you build your 3D sketch line, that's when you're going to want to come into the electrical tab under tools and say, oh, let me get out of that sketch, go to tools, go to define routing path, and I'm going to convert that sketch to a EW path. So it's going to say 3D sketch in my feature tree, and then it's going to convert it and call it an EW path. And that's what's recognized by the software to route. So I like to build a little segment here inside of my inside of the part, and that way, when I decide to build my EW path at the top level, right, or the subassembly, I have a starting point, so I don't have to go and do a 3D sketch and kind of zoom way in and try to find the center of this. And then, from here, at least I can just use this endpoint and draw another path and keep going. It just helps to make things a little bit cleaner, a little bit nicer, a little bit faster. So once you do that and you set that up, at this point now you can go ahead and use the electrical routing capabilities, whether it's wires, cables, or harnesses. In this case here, what I've done is I've taken all of this and I've turned it into a harness. So go ahead and just route a harness real quick. And you have the option of doing splines or lines. Splines just make it look more realistic. All harnesses, if you have multiple harnesses, in this case it's just one, so I'm going to leave it there. And then your routing parameters. This is something that is, if you get to a point where it doesn't look like something's routing correctly or something doesn't show up, you might need to come in here and change your routing parameters. Okay, and that means it's just a matter of how big is my assembly. If you're working with a small device, well, you might be able to drop this down a lot lower. I was working on, for example, a project that was a little tiny mini drone, and it was like zero point 0.4 or zero point 0, I can't remember what it was, 0.09 maybe or something like that. Whatever the low, like really low. And that really constrained the wires to follow that path almost perfectly. Like it barely bent off of that line at all. However, if you're working in a larger assembly, for example, I went to there was a motor manufacturer out in Ohio that they were using this, and they were using it for their raceways up above the machinery. Well, they don't need a 1-inch parameter. They could use it like 2 feet because it's just such a big assembly that it was okay to increase this a lot. They had a little bit more leeway on how stringent this had to be. So it depends on how tight you really need these lines to be along this EW path. Will help how it routes. Now, what are these two numbers for? Well, the first one is the EW path. They don't have to be connected. Like I have all of these connected all the way through. But in reality, I can have one here and then a space and then another one and a space and another one. Now this is going to determine the gap between those spaces, right? So in this case here, if there's a 1-inch gap, that's okay. However, if this path here and if these two lines, if there was a gap in here larger than 1 inch, what's going to happen is the wires are going to come out and they're going to get to that point where the gap is and go, oh, there's no other lines. Or if there's another line closer, it's going to jump to that. Or if there's no other lines around it, it's just going to stop there and route how it wants to route. It'll just jump. It'll essentially follow this path, stop there and go whoop, screw all the other stuff here and continue on and go to that next point. The second one here is the distance between the connection point and the EW path. So you can see here, I tried to get them close to the end. So what's going to happen is the connection point here is less than an inch. So what would happen is it would start, and if this EW path was further than an inch away, it's going to go and just route where it wants to route and not follow that path. Okay. You can always go in and try drawing a graph and making sure that your paths look right. Depending on how many connections you have in here, that graph might look completely ridiculous and overwhelming. But once you clean it up nice, the graph should come out and look really nice and just kind of follow your same path. All right, so once you get all that done, I wouldn't worry about your algorithms. I just leave mine on smart. Most folks don't even touch this. This is just different options. Even talking to the development team, they don't really mess with these at all either. But we'll go ahead and just route the harness. So what it's doing right now, it is looking at my parts, all those solid parts that we have, parts in the assembly, not the assembly itself, and looking at the parts, and then also looking at the connections, looking at the components and the connections and routing the wire type, right? Because there's properties behind these wires to tell me that, oh, this is a 12 gauge, 22 gauge black wire in here, right? So it's giving me all that information, and it's creating our harness from here. Now from here, there's a few additional things. You can see here that all those parts are inside of that new subassembly of the harness. I can now come in and I can flatten that route if I wanted to. I can define segments like this. This, for me, I would consider this to maybe be the trunk line here to kind of make sure that's the straight segment of it. If you use form boards and you need to do a larger assembly, you have this option here. You can define the size of that form board. You can do connections, a drawing sheet if you needed to, add your circuit and information connector tables. There's a lot more you can do in here as well. Go ahead and see what this looks like. So from here, before I added it to a drawing, I probably could have came in and maybe cleaned up a little bit. Like my splice, I could have cleaned up the angle on it here a little bit more to show that. Move these around a little bit more to show a little, make this fan out a little bit cleaner. I would have done that before I dropped into a drawing. Um, but now I have my drawing and I can shrink these tables down a little bit. I can, there's a lot you can do with this, but it gives you all the information. I know this is a little overwhelming with all the different tables and stuff we've got on here, but you can see here that we have, oh, here we go. Nope, I don't want the balloon. I want that guy. There we go. So this is just a matter of kind of tidying up the drawing itself. Once you do this, you can save this as a drawing here, or you can actually take this and you can push this. Once you clean it up, you wouldn't want to send it like this, but you can create a project drawing. So now you can take this and you'll get a notification here in a second. And we can come back over to our electrical project. And we can, let's see, where did it go? Nope, I have a drawing in here somewhere. I just got to figure out where the heck it went. There it is. Looks a little obnoxious, but I pushed that harness drawing back over into the actual electrical project itself. Now that's one way of doing it. There's a few different ways. Some folks like to populate the tables back over here on the electrical side rather than let the SOLIDWORKS mechanical side populate them. If you do that, if you want to just pull the actual harness and leave the ballooning and the tables for the electrical side, I like that way because then the tables are all dynamic and linked back to the schematic, right? Because that one, where is it? If I make a change to this or I change the pinout, the connection tables that are here are dynamically linked right now these are just static tables for this because you pulled it from the mechanical side. So those are the little nuances that, just to be aware of. If you want to get to this level, you can. I think ultimately I'm getting a little carried away on explaining some of this stuff, but hopefully it's beneficial. Just trying to explain the whole process going through this. So um, let me know if you have any questions, any concerns. I know that was a lot that I just threw at you. Um, I think the biggest question that you had obviously was about the C points, the connection points for each one of those components. C points are typically used for piping and tubing or electrical manually routing electrical wires, right? So there's electrical piping and tubing. Those are in the SOLIDWORKS Premium package that you can manually route your wires. If you decide to use this, great, that's fine. If you were trying to route all of those wires that are in here, which in this case is not a lot of wires in our um, schematic. However, you have to go in if you're going to manually route these, select point, side one, find side two, and then create a sketch line. You got your route. Do the same thing for the next one. Do the same for the next. Do the same for the next, right? And so depending on how many wires you've got, that can be pretty overwhelming to draw and manually write all of these out. Now, if you do and have connections or components that have electrical and, let's say, pneumatic or hydraulics in them, you can have the connection points that have the 0_0, right? The electrical connection points and C points to define those pipes and tubes and whatever else you want on there. So you can have both, but you do need to build them into the part, not the assembly. Okay. So again, I recommend if you have some sort of assembly that you're trying to add the connection points to, save that assembly as a part and then pull it back in and mate it up and then link and do that handshake like I showed earlier with J1 down here, that you can, do that handshake and it'll make sure that link goes between the two. If you're doing tubing, piping is really the only one, but if you're doing tubing, you can always do the tubing in electrical as well, right? If you're using, a manifold, for example, where there's electrical and pneumatic, you can have one circuit be the electrical and another circuit be the tubing or the whatever for pneumatic, if you have a supply or a drain or whatever it may be for air. So um, I hope this helps. I know I get a little carried away. It's almost 30 minutes long that I've been talking now. Um, in the email that I'm about to put the link to, this is going to be a private link on our YouTube channel. I'm also going to provide a separate link that has just all the videos from our YouTube channel, just so you can kind of pick and choose and kind of maybe go through and maybe help guide you in the right direction with some of your design stuff. So again, have a great day, and we'll talk soon. Thanks again.